AS level stats. So introducing something new for you guys, hopefully it helps. So we have a 5-sided fair spinner, which I forgot to write down, labeled 1 to 5, the spinner spun ones and scores recorded, name the type of distribution. So if the probability of getting each thing is the same, it is called a uniform distribution. These are things that aren't really teachable, it's for you to learn, put on flashcards and remember it. So a uniform distribution. Okay, now we have a spinner spun 28 times, we have a random variable x, which represents the number of times the spinner lands on 2. My big hands got rid of some of the writing. And okay, we have a random variable. We want to distribute this random variable binomially. And we know this mainly because 1, you're an AS level student, you haven't learned another type of distribution, but 2, when you do come and compare it to the normal distribution, we don't have a mean, we don't have a standard deviation. Don't worry about that now. We do have an n, which is 28, and then we want p, the probability of success, which, well, it's a fair spinner, it's a uniform distribution. If you can get 5 different things, the probability of getting one thing is a fifth, which is 0.2. Cool. Now we can start on part 1. We want to find the probability that it lands on 2 7 times. So we want to find the probability. Now, I miswrote this. The question says at least 7 times. So we have x is greater than or equal to 7. Now, this is where a lot of students struggle. They don't know when to do this 1 minus thing. Most of the time you're just taught if it's c greater than, do 1 minus. But the way I like to explain it to my students is, do you remember when in GCSE you got questions about, let's say, red beads and white beads in a bag, and we wanted to find the probability of getting at least 1 red bead, right? I'll put it on here. You had 2 options. Well, if we think about it as a tree diagram, you can get red and red. That would give you at least 1. You can get red and white. That would give you at least 1. You can write white and red. That would give you at least 1. The alternative is to find the probability of getting white and white, and then doing well, in this case it would be less than 1 just because of how the numbers look, but doing the probability that r is greater than or equal to 1 is the same as saying r is 0 or less than 1, okay? And this kind of translates here. Probably could have picked a slightly better example with a different number, but that's where the idea comes from. So you can't find it being greater than 7 just because of how the graph works, and hopefully your teachers have gone through that with you. So in this case, we will do 1 minus the probability x is less or equal to 6. Now, the hard bit, using your calculator. See this? £25 calculator. You can find it on eBay, though it is discontinued, but there is a newer version of this out. Get it. If you want to spend £80 on a calculator, I will judge you, because it's too complicated and it's going to take you about 4 months to figure out how to use, and it's just unnecessary. So I'm going to talk you through how to use a calculator like this. So you click menu, you go and find distribution. Great. And there's 2 options for you. You've got binomial PD, binomial CD. Another place for you to get confused. Do you use CD? Do you use PD? Well, CD is cumulative. We are looking at less than or equal to 6, which is 1, 2, 3, 4, 5, 6. We are looking at the probability is all the way up until 6. You are doing like cumulative frequency. So yes, we want CD. So we click that. We don't need a list, we just want one single number, so a variable. That's the one you're going to use most of the time anyway. X is 6. N, 28. P, 0.2. Click equals, there's your answer. It's now stored in the calculator, so we click this, and you know what, it's probably good practice to write 1 minus 0.678 ... But what we want to do is have that answer stored and do 1 minus answer equals, and write that down. 0.322 to 3 SF. Lovely. Part 2 is find the probability that 4 is less than or equal to 8, less than or equal to x, which is less than 8. So you've got to remember that this is discrete data. So it looks like bars, right? So you got like this, whatever. But I am not going to draw bars mainly because it's going to look messy, and we're just going to do it as a line. So it looks like continuous, but essentially those are your points. So the first thing we want to tackle is the probability that x is less than 8. Well, if it's less than 8 for discrete data, that means it's anything to the left of it. So we're looking at the probability that x is less than or equal to 7. Cool. And if probability of x is less than or equal to 4, so that's greater than, then, as we spoke about earlier, if this is 4, we again want anything to the left of it, which is going to be given by this 3 here. So anything greater than 4 is the opposite of less than 3. And the reason we do that is because to get this area between the 4 and the 8, we do the entire area of before the 7 minus the stuff before the 4. So it ends up being the probability that x is less than or equal to 7 minus the probability that x is less than or equal to 3. So grab your calculators just like we did earlier. Menu, find distribution, go on to see the variable. X is 7, n is 28, probability is 0.2. Write in our answers. 0.81823 ... and then sub that out for 3, 0.160182. Now you could learn to use your letters here, A, B, C, D, to store your answers. It would be quite useful, but I've written enough decimal places on my screen, or on my whiteboard, just to do the probability of x is less than or equal to 7 minus the probability of x is less than or equal to 3, and then I would just put these numbers in myself. Minus and 0.657 to 3 significant figures again. So that was something slightly new, a little bit different. Hopefully you found it helpful. If you want to see any other questions like this, drop it down in the comments and show some support by liking this video.